Rossi and Mark Sendak here from DHI. So, we all struggle with challenges throughout the world of healthcare related to issues of quality, access, and affordability. And here locally, there's been several years in the making efforts to try and evaluate ways of delivering care that actually help start to solve some of these issues. But these sorts of solutions require transformative ideas and partnerships across disciplines and a nidus for all of that work to occur. So today, it's a real pleasure to have two people who are knee-deep in that work. Will is a former grad from Georgia with an MBA who leads the partnership development and the Living Lab for Innovation here within DHI, which is an institute supporting the implementation of new care models and novel technologies within care settings here at Duke. Before this, he worked as a special assistant to the Chancellor of Health Affairs and was responsible for supporting a variety of Chancellor-directed initiatives, one of which included the launch of DHI, which resulted from work at the World Economic Forum in Davos several years ago, as well as helping to develop a variety of models for CMMI opportunities. Mark Sendak is a med student extraordinaire who's also received a Master's of Public Policy here at Duke. He leads the analytics efforts for DHI, overseeing a team of statistics and computer science interns, managing population health analytics projects, and developing capabilities to support a variety of Duke investigators across a variety of specialties, trying to gain insights from healthcare data here in our own system. A non-trivial task, as many of you may have found. He's also a medical student in the primary care leadership track with a background in math and health policy. Before joining DHI, he spent 2 years supporting the DOC as a data analyst. He's passionate about building tools to drive population health management programs, and really I think you'll enjoy hearing about some of the work they're doing here at Duke. And also it's a chance to think about how your work might interface with DHI and expand opportunities to improve care for patients here at Duke. So please join me in welcoming them today.
Well, thanks, Dr. Patel. I think that what we want to do today is really just talk to you about DHI, what are our activities, how do we source innovation, and then what is the infrastructure that we have to support the implementation of innovation. But it's really good to be here at DCRI because over the last 2.5 years since DHI was founded, a lot of the innovators that we support are actually DCRI faculty as well as DCRI fellows, and who have just been absolutely amazing to work with. So, what we hope, especially after Mark talks about an analytics case study, how we're putting this into practice in the clinical setting, we hope that you can see what we're doing, where we're focusing our efforts, so that we can find out from you, like, how do we best collaborate? What are you all doing? What are you all thinking that you can actually leverage what we're putting in place? So DHI, like I said, was founded back in 2013, so still relatively nascent organization. But the way that we bucket work is through 4 really distinct pillars. And there's a lot of blend between them, but it kind of helps us kind of parse it out. The first is implementation and health delivery science. So that's about new models of care, creating a structured interface for faculty and staff to the Duke University Health System, and then also the Living Lab for Innovation, which I'll touch on in a little bit. The second is health technology innovation. So here I'll touch on 3 things, 3 of our activities here. The first is a partnership that we did with DHTS, where we're able to create a framework that takes data from mobile apps and digital technologies and push that directly into the EHR. So the reason why we think this is really novel is because once the data is there, you can put rules engines and algorithms on top of the data to be able to send alerts to clinicians at the right time and hopefully shuttle patients to the most appropriate care setting, which is hopefully the lowest cost. I guess the typical patient probably spends 3 hours in a year face-to-face in front of a clinician, leaving 8,500 hours where they're at home. So how can we take data that's being generated in the homes, data that's being given by the patients themselves, and be able to use that to construct a care model that would be most appropriate for patients? The second is, I'm sure whenever you all travel around the country and are striking up partnerships either with other academics or with industry, the beauty of Duke is really the wealth of data assets that we have here. From leveraging our clinical legacy data, but also the DCRI being the largest academic research organization in the world, doing trials all over the globe and being a coordinating center for many of those trials. Being able to take that data and partner with machine learning experts to be able to learn from that is vitally important, and something that Mark especially has worked to create and build a marriage between the quantitative sciences and the clinical settings. And third, I'm sure a lot of you are familiar with what Apple did with HealthKit. Our mobile developers, Mike Rovar and Jamie Daniel, worked on the Research Kit app of Autism and Beyond, where they partnered with ORI. And Research Kit is phenomenal because you can not only collect data from patients, but you can actually actively enroll patients and consent patients via the phone, which makes any trial you do immediately scalable across the globe. The third pillar is health leadership and workforce development. So if we're going to create a culture of innovation within Duke University Health System, how do we actually cultivate I guess like the skills that people need to be able to know how to drive innovation? How do you drive new models or new technologies within the care setting, whether it's your clinical environment or whether it's your business environment? So that ranges from backstopping MMCI to leadership programs for medical students and trainees. We also have a data analyst internship for undergrads in the departments of statistics as well as computer science. And you'll actually see their pictures a little bit later when Mark talks. Finally, if we were to pilot a bunch of new models of care or integrate technologies into the care setting and it stopped there, like that would be good. But what would be even better is if we were able to take the outcomes from that, take the successes from that, scale it up, and then take those learnings and turn those into recommendations to policymakers at the state and federal level. And leading this charge has been Mark McClellan, who's actually now here at Duke leading the Duke Margolis Center for Health Policy, as well as I know Kevin Schulman has been very interested in this for a very long time in leading these efforts. So, but how do you take these learnings and actually allow policymakers to know how do we change regulations and how do we change payment to allow for this model or these models to continue? So that's kind of DHI and our activities in a nutshell. How do we source innovation? How do we choose or come up with the projects that we're going to really focus on in the year is a question we get asked a lot. So the main way is through a request for applications. It's a yearly process where we work with leaders from across DukeHealth to identify what are the strategic areas that they think innovation can play a role in providing a solution to some of the problems that we have. So the first area from this past year is population health and analytics. Second is novel patient interactions. So how do we engage with patients better? How do we educate both patients and caregivers more effectively? And then how do we just overall improve patient experience? Third is novel and team-based models of care. And then finally, how do we just optimize patient flow? So this could be from the ED to the floor, it could be within radiology, it could be from hospital to hospital within our system. So this year we had 62 applications. Last year we had 61, and the year before it was 60, so we are on an exponential path forward. But of those, 16 ended up presenting, and we'll actually be making the announcement hopefully by tomorrow, but definitely by the end of this week on which ones we'll fund. The other way that we do it, the other structured way, is what we call the Innovation Jam. So it's really a Shark Tank style program where we take ideas that faculty and staff have that have commercial potential. And we bring together department chairs, the head of the hospital, the head of the faculty practice. DCRI actually was an investor as well. They all invest their own money. I mean, not their own personal Wells Fargo, but the discretionary funds that they have available to them. This year, we had 8 pitches, and 6 of those ended up getting funded. But before I turn it over to Mark, I want to spend a little bit of time talking about the Living Lab for Innovation. And this nomenclature is not something that's novel to Duke. If you go around the country, you'll hear about this type of approach. What we think is novel is the way that we've constructed it. So if you go to other institutions and you said, hey, I got a new model of care, or I want to take this technology and integrate it into the care setting, they'll say, that's great. Here's a physical address that you go to. We're going to funnel a panel of patients to this physical address, and this is where we test the innovation. But to us, that's a very synthetic environment. It's hard to know, how do you validate the outcomes that you see in a synthetic environment to a real-world clinical setting? So we actually want to take our clinics and clinical settings that are open to testing new models of care. So this is Duke Primary Care, the Heart Center, specifically the same-day access clinic for heart failure with Zubin, and then also hospital medicine. So clinics that are just open to testing these new models. But what we know is we also have to provide them with a core set of capabilities to ensure the success of that implementation. Things like access to data for these projects, analytics and visualization tools. So Mark's going to talk a lot about chronic kidney disease, but if you had a new model of care where you really thought you could mitigate the decline from stage 3 to stage 4, and yet you implemented this model of care on all patients, it's going to look like that model was unsuccessful. But really, was it unsuccessful? It wasn't. It's just you implemented it on the wrong patients. So we're talking about basic risk stratification to predictive models to actually incorporating machine learning methodologies to learn more and more about patients. Third is project management support. We really want to provide that for the innovations that come through the Living Lab, because what we know is you're incredibly busy, and managing these projects is something that can be very difficult to do. So we want to take that on. We want to take that on for you. The last one I'll mention is measurement and evaluation. There's so many brilliant people across Duke in quantitative sciences, and how do we partner with them on the front end of a project, but also on the back end after the project's completed to prove the clinical utility of a project, but also if we implemented this with patients that are in a provider contract that is at risk, how do we actually prove the economic utility of this intervention as well so that we know how best to scale it up? So that's the Living Lab, and that's what we'd really like to have as really a responsive infrastructure for all of you to be able to use to drive innovation. But I'm going to turn it over to Mark. Mark is going to be going back to the wards in a few weeks for his 4th year of medical school, and Mark has been absolutely phenomenal for DHI. Just his brilliance and ability to create a marriage between quantitative sciences and the clinical settings, and then driving a whole new model of which he's actually termed population rounding. So I'm glad that you'll be able to really talk about the work that you and also Dr. Patel have been able to do.
Thank you, Clicker. It's an honor to be here. I've had the pleasure of working with Dr. Patel on this for, I think, the last year. And I was brought on at a difficult time. I was first started talking with Suresh in September 2014. They knew they wanted to do more population health and analytics. And from the get-go, the task wasn't just to do good work. It was to figure out how Duke can do this work, and entering the position thinking, how do I replace myself and scale myself in a year and a half. So I'm going to talk through kind of one case study of what it took to execute on one analytics project, take a step back, look at the finer details of what the team had to do that, and then think bigger picture, what sorts of things do we need to have in place for DHI to continue to execute on these projects, as well as university side efforts that are trying to increase collaborations with clinical faculty. So this was a pretty unique project. It was the first time that both DTRI and DHI kind of went in together on a project to both do research and development around developing new quantitative models to identify progressing chronic disease, as well as having an implementation partner, which was for us the Duke Connected Care. It's a Medicare shared savings program, helps manage care for 46,000 Medicare patients. So this was an amazing project because as we were building things, we were also getting live feedback on the utility of it from a real clinical setting where we were trying to take action on patients. So to think kind of more generally, what are the major problems with healthcare data? So in the middle, you have a single patient, and then kind of these three different places could be three different hospitals. One of them you could call a payer, so an organization collecting claims data. Within any one healthcare system, you have multiple data systems that are collecting data in parallel. And then you have deprecated systems that contain legacy data from some point in the past. Within a system, these different silos are not kind of talking to each other in a standardized way, and then between different systems, they definitely are not talking to each other. So this is the status quo, essentially all over the country, maybe except for Kaiser, the VA. So what does that mean for individual patients? It means that data is kind of stored and collected in different places. It's not organized in a way that's clinically meaningful, and that means that things can go undetected for far too long and patients are falling through the cracks. So the first thing that we did when we started this project was just went out and pulled everything that looked like a serum creatinine lab. So I had been working for 2 years at the Duke outpatient clinic and had shown Dr. Ebony Boulware the type of work I was doing to help monitor health service utilization. And she was the first person to point me to CKD because she was saying, you know, this is a single biomarker that we have data on for 20 years. And we've never kind of consolidated all of that data and formatted it in a way where we can track patients throughout their history at Duke. So what you see here is a single patient and 15 years of chronic disease progression. So each point is an eGFR value, and you see the horizontal lines kind of demonstrating the different stages of CKD. There's a clinical guideline saying that once patients pass an eGFR threshold of 30, they should be referred to a subspecialist. The first time we see a subspecialty visit in our own system from our EHR data, their eGFR is back down to 20. And if you look at time periods, this is about a year late. Thankfully for this patient, once they were referred to a subspecialist, they did remain engaged in specialty care. But the question is, could we have done something sooner? Obviously, we're collecting these data points. Where was the patient hitting our system? And unfortunately, this patient was in primary care. For the year preceding the nephrology visit, you can find 6 primary care appointments at the Duke outpatient clinic. And then you'll notice that where most of this data was coming from was the emergency department or hospital admissions. So the sad thing was that for this patient, by the time I went and built out this data and cleaned it all, it was too late. This patient died towards the end of 2014, but for other patients in our system, it's not too late. Around that same time, we identified a patient who had not yet seen a nephrologist, who was rapidly deteriorating. And the question is, could we do more for these patients? So Uptal Patel frequently kind of draws upon his experience in the transplant clinic and the many patients that he sees in clinic that are told, you know, this actually was progressing over the last 5 to 10 years, but why didn't anyone tell me sooner? So let's take a step back. That was for one clinic, just seeing, is there a problem here? Is there something we can do? Once we saw the data and there was an opportunity to improve care, then the question was, how do we do this at scale for an organization managing tens of thousands of patients? So we weren't going to make plots of 46,000 patients and have someone go through it. So the first thing we did was, well, how do we identify the patients? There's 2 papers in JAMA, 2011, 2014, that identify both 2- and 5-year risk of progression to end-stage renal disease. The top is Tangri's kidney risk equation, probably the more widely used, I think, risk estimator for CKD. And then Koresh published something saying if you demonstrate 2 years of a decline at a certain rate, that's predictive of that's an intermediate outcome for ESRD in the future. So what I show here is a distribution of risk for the 46,000 patients. And similar to before where the threshold for referral was an eGFR of 30, here the threshold for referral is an estimated risk above 15%. So fortunately for our MSSP program, most of the patients are low risk, but there are about 2,000 patients who had risk levels above 15%. So we got together with the group, and 2,000 was more than we expected. So then how do we kind of continue to drill down to the right patients? We set up some inclusion-exclusion criteria. We wanted to focus initially on the high-risk patients who had not seen a subspecialist who we thought may need subspecialty services. So the first thing we did was exclude anyone who we could identify a nephrology visit. And the trouble here was that we had to build these exclusion criteria based off of easily accessible structured data that we could get out of the EHR. So we were able to eliminate another 1,400, and that left about 400 patients left for rounding. So now I want to give an overview of what population rounding actually looks like. And thankfully I have some of the folks here who lead the team, especially Blake Cameron, but because it's kind of complicated. It involves the first thing, go get the data from all the different places, consolidate it, organize it, put it in a meaningful format. Thankfully, through the grants, we use that as a coordinating mechanism to get resources aligned from the ACO, their care managers, a pharmacist, social workers, and then feeding that into an analytics system, and then having people sitting at a table review patients one by one. And at this table, we had an interdisciplinary team led by our kind of fellow extraordinaire, Blake Cameron. And then after a discussion for each patient, they would activate a care path for the patient, or they would say, you know, this patient may not need anything. So the results from the first 5 months was we got through about 335 patients, and unfortunately only about a quarter we ended up connecting to an intervention. Two things I want to point out that I'll kind of touch upon later. You'll see the jump. The first 3 months we were averaging about 50 new cases per month. The last 2 months we were doing about 100 cases per month. And then you may notice in the table of kind of what the outcome was for individual cases, a lot of the patients we actually found met our exclusion criteria. But the problem was we couldn't identify outside nephrology visits easily from structured data in the EHR. So we realized that there is a big limitation working with EHR data to really apply your inclusion and exclusion criteria rigorously, and it takes a lot of manual abstraction in the chart. So that got us thinking, you know, the whole goal here was to do two things. One was to accurately identify patients with progressing chronic disease, and the second was to optimize the workflow to quickly connect those patients to services. So what I didn't show was how we did those 5 months of rounding, because it was not sexy at all. It was a spreadsheet, and they kind of told me which columns were more useful, which columns were less useful. Hey, it would be really cool if you could also throw in the date of the most recent eGFR, or if you can show which clinic these patients are attributed. So it was very iterative. Thankfully, Box keeps track of changes. We're on document 87 for the data pipeline. So yeah, we're nearing 90 different iterations of the data pipeline that was feeding spreadsheets to this interdisciplinary team. But we wanted to get away from spreadsheets because we think there's a better way to see this data that will allow people to make their decisions in a more informed way. So everything I'm going to show you here is synthetic data that's generated. But this is a real web app. This is functional, this is interactive. Right here it just looks like static images, but this is one of the more exciting parts of the project, is that we're also able to engage some top-notch software developers. So this is when, let's say, you're tasked with identify patients with progressing CKD within a population of 46,000. Here's what individuals look like. So on the far left, you can't see super well, but the column on the far left, the title is Tangri. That's one of the risk scores. I think here it's 5-year risk of ESRD. And then the second column is delta eGFR. So that's just a linear regression over time of their eGFR, so it's just rate of decline per year. And then on the far right, you see flags and diagnoses. These are things that we built out in different iterations as we kind of learned from the team what meaningful data were they using in their decision making. So if a patient was already on dialysis, they wanted to know that. If a patient was rapidly declining, they wanted to know that. They wanted to know CKD, diabetes, hypertension. So you start out just seeing all the patients, and then you define kind of how do I want to drill down. So the parameters I put in right here, I'm saying a rate of decline of at least 5 per year, and then a Tangri risk score of above 15. The first thing that jumps out is from these 5 fake patients, 3 are already seeing a nephrologist, which is great. So maybe not need to review them, but then you'll just review the 2. And this gets us to a workflow that we call pre-rounding. So before I showed that we were doing 50 patients per month and then jumped up to 100 patients per month. And what we learned there was that it's not worthwhile to have multiple MDs at a table, a pharmacist, a bunch of very intense resources to jump in a chart and find that a patient died 2 weeks ago. There's no reason that we should show you 5 patients who just died. So why not offload that to someone who, just anybody with Epic read access can quickly go through and fill out a form to say, read through the last few notes, this patient's still alive. Or read through the last few notes and this patient's not on dialysis. So what you see here at the very bottom, once again, a little hard to notice, at the far right is an approve button, and at the left are buttons for deceased, distant from Duke, on dialysis, in hospice, or seeing nephrology. So one by one, someone will just sit there and fill out the form with Epic open, kind of just abstracting the structured data in order to allow us to more efficiently include and exclude patients. So after we've kind of continued to curate the list, then we get to the folks that we want these intense resources to discuss in person over a 1-hour-long meeting. So here you see kind of longitudinal plots of the different lab values that are included in Tangri's equation. And then at the top, you can see that we can assign tasks. So as someone says, okay, this patient hasn't seen their PCP in 2 years, I'll just send a task to the care management or general team saying, make a PCP appointment. Maybe a medication hasn't been renally adjusted. So then the pharmacist will put that on his task list. So to make use of all the disciplines that are coming around the table and efficiently coordinate their workflows so that they know what they have to do for each patient. One of the most amazing parts of this project was the speed in which decisions could be made. And they often said it was actually because of Blake and the way he was making these decisions, but we timed 6 sessions, a total of 72 patients, so average of 12 patients per session. Average time per new case was 2 minutes and 12 seconds. So these are relatively fast decisions, and this is a lot more efficient than sitting in a clinic and having to see these patients one by one. So you assign tasks, make a comment, maybe patient relies on neighbor for transportation, so maybe tough to physically see the person. And then you say, okay, when do I want to revisit it? And so you see a calendar pop up, say I want to put this patient back in the shuffle to review in 3-6 months, et cetera. You go to your home page on the app, and then it shows which tasks were assigned to the group that you're a part of. So the user that I'm logged in as now is part of the general group, so these are general tasks. Whereas this list would look very different if it was Blake's list, so a nephrologist. Then it may be, hey, email these PCPs asking for continued workup or to kind of ask questions about the management decisions. So part of the project was how do we develop a tool for the ACO today that they can use to better manage CKD in their population. I mean, this is an organization that's financially accountable for this now. So for the DHI pilot to be successful, we had to start doing something useful to them. But as part, kind of the main thrust of the DTRI grant was, well, these risk models only look at the most recent value of labs. And for a lot of these labs, we have years of longitudinal data. So why don't we take that into account, start going beyond point estimates of a predicted outcome, and then start predicting trajectories. So thankfully, our PhD student, Joe, joined us. So if you have technical questions about model building, I would want to defer those and direct those to Joe. But quick overview, you can see just 10 patients here. Not only is there high inter-patient variability, so you can see pink at the bottom, huge swings within months. Some of these labs are maybe even within weeks, large swings. So there's high inter-patient variability, but then also between different patients, there's not kind of a uniform monotonic decline. Some patients are recovering, others look like they have steady patterns. So this is what the raw data looks like. Joe was able to smooth this by taking monthly averages of different values and then use historical data to predict future. So what you see here moving from top to bottom, in the top, he's predicting future based off of the first third of lab values, so the blue dots, and he's hiding the green dots, but the green dots are real. In the middle, now he's showing the model, the first 2/3 of data and predicting forward, and at the bottom, it's all of the real data and predicting forward. And interestingly, I pulled, this is the one patient that you provided the image for, but correct me if I'm wrong, but this could be clinically meaningful, because let's say this patient is in their 70s. Their kidney function's not normal. You see that it's in the 50s, but in the bottom, even at the 2.5% confidence range, this doesn't drop below 20. So maybe there's no reason to refer to nephrology, because you're not suspecting that this patient may ever actually need dialysis, even though their function today is not normal. So the goal is, can we do a better job of not only predicting point estimates, but predicting trajectories, and where we're starting to go now with Joe is predicting cardiovascular events. So based off of these longitudinal biomarkers, let's start seeing how well we can predict heart attacks and strokes based off of this. So it's been an amazing year. We've done a tremendous amount of work, but it was a very hard project. And this is probably the one DHI project that was almost exclusively using our own electronic healthcare record data. We did have another analytics project that the main goal there was to leverage a national registry. But the question is, if we want to continue doing this work, how do we do that, and what does it take? So this is a part of data mining that people are not so familiar with, because it's easy to talk about, but it's very difficult to actually do. So most of my job when I'm working with the data is to be that guy in the upper left. I have a headlamp on, I'm in Deduce or I'm in Clarity, I'm poking my head in different parts of the mine, understanding where is this resource that we're trying to use, and then you just kind of like chisel away at it and you pull out chunks of it. But what you're getting out is not a processed, like workable resource. It is something that has to, it's a lot of effort, and it's a lot of disciplines coming together. So I like this image because it has three people. So there's the guy in the mine pulling it out. There's a person who knows the mine inside and out. So for us, I don't know if any of you have had the pleasure of working with Stephanie Brinson. She now is an MSSP employee, so we get her time for the project. She knows Duke's data architecture maybe better than anyone I've been able to work with. And then lastly is a clinician. So we have someone who's both a subspecialist as well as an informatician or informatics student interested in the data architecture. So the three of us, there's emails going all around. Uptal's getting emails of like, what do we do with this value? Is this real? Is it garbage? So a lot of iterating before we get to the bottom left, where you actually have kind of a discrete block of something that makes sense. But then that's not the final product. The final product is to build data products that end users can consume, and to kind of chisel away from the refined kind of resource to build something that people can use. So this is just one example of how metadata changes within any EHR. So there's like 20, 25 different creatinine names. The one that I'll just point out is the cross from red to green. For probably the first 17 years at Duke, most serum creatinine values were stored under CREA. That was pre-EPIC. After EPIC implementation, it switched to creatinine, and then just lots of other kind of, maybe these are new labs that opened up or things got activated and deprecated. You don't have to do that for one variable. For Tangri, we had to do that for 9 different labs, 2 diagnoses, 2 demographic variables, and even the Tangri equation was just one piece of this. As we were sitting at the table in the app, you kind of saw the flags and filters. We learned that. We didn't know coming into this what we would have to build, but we started showing them Tangri scores and then seeing the discussion that was taking place. And I was physically in the room every week, kind of jotting down notes of what variables were people digging up in EPIC, because that's where most of the time was spent. It was clicking through EPIC to find the data element that you would use to make the decision. So we iteratively built out each of these different flags and filters, and then you could get to this concept of a rounding list that was useful. So broadly speaking, there's 3 kind of domains of expertise that have to converge around these teams of innovators that come to us with a year timeline. So this is relatively short projects, and they need support to kind of bridge these different domains. So you have clinical experts who have a clinical question, you have quantitative experts who have the technical background and technical skills, and then you have people with the data expertise understanding EPIC's backend as well as Duke's own decision support repository or our own data warehouse. So thankfully, as Will mentioned, a lot of our teams already include DCRI faculty, DCRI fellows. I'll call out Abhinav that we are trying to work with him more explicitly now to help kind of bridge between some of these pieces. Fellows are a huge part of what we do. So for example, faculty on our projects, some of them already come from the DCRI and B&B. Eric Huang is a PI on one of our projects. Blake, an informatics student, helps us bridge between clinical expertise and data systems. And then we have essentially had to create our own programming at DHI to help supplement this. So to help us work between the data expertise and quantitative expertise, we've started an internship. These are students with statistics or computer science degrees who have programming skills, maybe have never worked with healthcare data before, but know how to work with data. So they can help prepare the data from its raw output to where kind of the PhD students and stats faculty can consume and build models using the data. I'm kind of like the first med student scholar working with DHI. We have some clinical expertise. If our future scholars have technical skills, we can give them access to the data to gain some expertise and quantitative expertise. And then lastly, I'll point out that I have like DHI data team in the top right. We're in the process of hiring 2 additional folks who have understanding of Duke's data systems and a long experience supporting clinical teams doing this work. And the whole goal here is within a year, you have to get these 3 pieces to interlock and function well. So we did this for chronic kidney disease, but now we can think, why can't we do this for other diseases? And this is where we're starting to go. Our CKD project was very successful, so we're starting to work with Dr. Susan Spratt around diabetes and actually just got a grant with Dr. Zubin Ibn to do this similar work around congestive heart failure, in that setting focusing on readmissions. But the goal is to align healthcare resources, go organize the data, and then serve this to interdisciplinary teams. Some of it can be done synchronously, physically in a room together. Other pieces can be done asynchronously via email or phone calls. But how do we kind of bring these people together around data that we've organized to improve care provided for different chronic diseases? So that was doing this for one project. And then what the team dynamics were, what each of us brought to the table. So then what else can we do at DHI to support growing the number of teams trying to do this work? Because big picture, as I've mentioned, raw data to clinical action, a huge part of it we've realized is this processing engine where you're defining data elements and defining the phenotypes. So phenotypes is like a new buzzword in bioinformatics where you just essentially have one variable that has dependencies on a set of other variables, and there's a logic for how you define the phenotype. So we've learned that that's where we need to focus a lot of our energy. And so we're starting to build something that I'm calling the DHI Analytics Wiki, where we're consolidating our knowledge and understanding from the projects that we've been doing of how you define data elements from deduce, from clarity, what the logic is, and then how do you define these phenotypes. And as I mentioned, kind of phenotype just has dependencies, and then mapping each of the data elements to source data elements. And then once you get one phenotype, build out many, and then this is what really streamlines working with statisticians, because they don't want to worry about any of the stuff on the left, and we don't want them to. Like, we would be able to help them lead much more productive lives if we could handle the work on the left, and they can just take the clean phenotype elements and then build models off of that. So what we're doing is we're curating a repository of both the data elements and phenotypes. Some of them we expect that we're going to have to build on our own because they haven't been built before. But a huge goal of ours too, we're a small team. There's only 4 or 5 full-time DI employees. So we can't build all of this. We want to leverage what's already been done. So thankfully our project with Susan Spratt, she's been an epic champion and helped build the diabetes registry. So we're leveraging a lot of the data elements that she's already cleaned in her past efforts. Vizient recently acquired UHC. There's been a lot of population health metrics at Duke that have already been built for UHC, so pulling those in. Same with DCRI, SETI, phenotype, and models, bringing those in, and then just research more broadly. Anything that's published in PubMed. If you're a collaborator and you find some new diabetes phenotype that you want to use in your project, send it to us. Hopefully we can provide you the support to build that using what's already existing, and then add on to that what we have to custom build. So here's an example of what this actually looks like. I just started taking this on about a month ago when I realized, like, oh my God, I go back to med school and I have no idea how to dump all of my knowledge somewhere. But it needs to be organized at both atomic data elements and then what we're calling compounds. So similar to a single data element and then a phenotype with dependencies. So this is for serum creatinine, which for us was hugely important for the CKD project. So, okay, the big thing here is how do you get it from deduce? What are the different lab names? So I'm going to just go through a few of the different ways that we like to drill down to understand, are these things measuring the same thing? Are they measuring different things? is this the right definition or the wrong definition? So here you see descriptive statistics for the different lab names. Notice the top two, CREA and creatinine, cover almost 4 million of the 4.4 million serum creatinine values ordered at Duke, so it's the vast majority in those top two. And then as you move to the right, it's just how fat are these distributions when you get to 2, 4, 6, 8, and 10 standard deviations away from the mean. You see everything kind of drills down to 0 towards the right. So things are at least centered similarly and taper off when you get far from the mean. Once again, the metadata changes, so if you have an investigator looking at a specific time point, these plots are on the wiki so that you would know where you would find the data during that time frame. Here, box plots we think are really useful for identifying outliers. I'm not actually sure. Can you physiologically have values at 150? Yeah, so at that point, but keep in mind that's creatinine, so there's 1.2 million, so that's 2 out of 1.2 million. Those are probably errors. If you look to the far left, you see CREA, there's a few between 50 and 100, and that's out of 2.8 million. So here we're just showing like these things roughly measure the same thing, but there are errors in our healthcare data. Let's see where those are, figure out generally are they measuring the right things, and then how do we handle the errors. Lastly, just showing bulk of the distribution is weighted around the same place. So a part of this is the human readable wiki page where any of us can jump on there and see how do I define this variable. But for us, just as importantly, or maybe more importantly, in terms of bridging the quantitative sciences and the data, is let's try to automate this. That way from the wiki, we're linking you to SQL queries that if you want to run this, or you have someone on your team that can run this in Clarity, you can pull the data. We're going to give you, I do everything in R, but it'll either be R or Python. We're going to give you the processing script to turn that raw extract into something that's useful. And then for us, the kicker is we want to leverage these data assets. So we've built serum creatinine. Right now we have that in a private box folder that no one has access to, but it is the 4.4 million clean values. So Susan Spratt, a diabetes project that we're going to be working with, if she wants to use serum creatinine, we can give her access to that data element. And as we build these out one by one, these projects that are, for us, a lot of this is overlapping around cardiovascular disease, they can leverage the data elements that we've built out for other projects. So that's kind of the information resources that we're trying to provide our teams so that work does not have to be redone, and folks themselves can understand where to find the data that they need. And the last part of this is we're trying to develop the talent to scale these projects. So I'm going to talk about a few of our outstanding interns. One of them is in the room here today. So this is Owen Huang. He's been essentially the main and only software developer supporting Calypso, which is a project led by Dr. Eric Huang, a current DHI funded project trying to predict surgical complications. And he's a computer science senior. We're hoping he stays at Duke for his MD and PhD, which he was recently accepted to. If so, we'll work with him for the next 8 years. Michael Gao, a statistics senior sitting right here, has helped build kind of a primary care tool to allow clinics to better drill down and visualize which groups do they want to focus different interventions on. And lastly, for this project, it was mainly driven by trainees. It was me as a med student, Joe Futome as a stat student, and Blake Cameron as a fellow. And I think a huge part of this is that this really is advancing all of our careers. I think for Joe, this is the first part of a dissertation that may involve kind of further explorations into different chronic disease progressions. For Blake, he's trying to negotiate a job now where he can continue doing some of this population level work for the Medicare Shared Savings Program. And for me, I feel like I'm just ruined for life to try to build these technology kind of tools to support clinical teams. So thank you, everybody. It's been a pleasure and an honor. And we wanted to leave time for questions because a goal of us being here too is to help foster future collaborations. Do you want to make any?
Yeah, I would say the same thing. We just want to collaborate. So given what we're doing here at DHI, any way that we can be a catalyst to support your efforts is really what we want to do. I don't think this is on. Yeah, so any questions, we're happy to answer them.
Yeah, thanks, Will and Mark. You know, I'm looking at this, and this is a Herculean effort to figure out creatinine. And we only have 2,334 other variables. And there are only 5,500 other hospitals in the United States trying to figure out exactly the same thing. And so, you know, at some level, can you help me understand, is this expected? Is this what the world of IT is? If I gave this to Steve Jobs to develop the technology, would I have the same set of problems and we just have to grow up and live with it? Is this technology flawed? I mean, you know, if I figured out the economics of how much it figured out to identify one avoidable complication of progression of diabetes care, you know, what would that answer be? And it's not your fault at all. You did a great job with it, but that's the technology and the business problem and the business question. So, you know, at some level, one of these days, you know, Hamsday just said we got a B- in technology. We bought the wrong thing. So, is it the wrong thing? Is it fixable, or do we have to pivot to some other technology?
So I would not wish it on the thousands of health systems to do this themselves, but if there are investigators who rapidly want to test models, I don't think there's any way around it, especially if you're trying to use historical data. Yes, we can get around a table and agree that once FHIR is implemented and data is standardized and structured, we will not have to worry about this anymore. So for me, one of the more fascinating recent insights I got was, so one of the software developers we work with is a former Dookie who's the technical lead of data engineering at Box, the cloud storage company. So it's interesting now that technology companies in Silicon Valley are competing for talent, for stats PhDs based off of their own data pipelines, because stats PhDs data scientists don't want to get jobs where most of their job is cleaning the data. So now they're creating these whole teams called data engineering to streamline those pipelines to service these data science teams that can rapidly run models. And Joe, you may have something to add from your experience working both here and at companies that are expected to use big data in much more efficient ways.
Yeah, I mean, so I did an internship at Amazon this past summer and spent a lot of time doing data cleaning type stuff. And so, I mean, that just wasn't like a role that I really wanted to have. And I think it obviously depends. Different companies do things differently. And so being at a company where, I don't know if Box is going to this model or whatever, where you have people that are doing, you know, quote, data engineering and kind of handle the pipeline makes it a lot easier for someone with like my skill set and my interest to do the actual modeling and like the data science work and to not have to worry about like the data cleaning and sort of getting it from this raw form into a more usable form. Because I think Silicon Valley is obviously ahead of healthcare in certain respects, but I think it's a general issue just for any company to have to deal with their raw data, because when the data is being collected, you know, from some streaming service like Netflix or whatever, there'll be like these giant logs and data dumps, but like that's not being collected to build models. It's being collected by some data, you know, person that like wrote the logger or whatever. So there's a step in the middle between getting the data from this raw form into the form you can use. And I guess basically any industry has to deal with that, and just different sectors of the economy are in different places, right?
Yeah, I was struck that that problem has not been solved, even by leading software companies, and that they're struggling to do this as well, and they're recruiting talent based off of what they're boasting to have available. But
the difference in Amazon is they're solving the problem once. You know, 250 people are doing Epic, and they're all solving exactly the same problem.
you're right that, but I mean, Joe, you were one analyst at
I don't
Amazon.
even know if I would agree with that. I mean, I think it just depends on the company. So in my case, I was like in this very siloed team working on this one thing, doing things that honestly had probably been done in other parts of the company, looking at some of the same logging files for this certain, I was working on like streaming music services. So I don't even think that's necessarily true. I think it depends on like, you know, how open to collaboration, sort of how much people spread their knowledge at whatever company you're at. So I think like it's not a unique thing for, you know, healthcare systems to be, oh, we all have to do the same stuff in Epic. I think that probably happens in other big companies.
I want to take what Kevin said and push it a little bit more. First of all, let me just say that I think this is an amazing accomplishment that you all have done, and you really deserve to be congratulated.
Thank you.
But I agree with Kevin that we have an incredibly bad, this reminds me of the early days of Microsoft, when we were struggling to do very simple things with an operating system and programs that sucked. And they would put out these programs and we would beta test the program for them. You know, we would find the flaws, we would find the holes, we would find the ways it the different components didn't interact with each other. And a lot of time and energy was spent just making your stuff work decently. And when I think about innovation, I think about disruptive new ideas. I think about who's going to kill Epic. I would put a lot of money behind whoever is going to kill Epic.
I would love to kill Epic.
Let's go for
Love
it.
that.
You would get incredible amounts of support if you could come up with a disruptive way to put Epic out of business.
But, so, this is not enjoyable work. Let's just put that out there. Like creating these plots, digging through these tables, creating tables, and then digging through the tables with other people and getting different people's input. But I think for us, where we keep coming back to is everyone's talking about big data and machine learning, and that stuff is, like, this is necessary for that. And even a lot of this is outside of Epic. So let's say serum creatinine, we're gonna, hopefully we've nailed a decent enough definition. But even then it needs to be dynamic. This wiki page will have to be refreshed every 3 months because there may be a new lab that opens up down the street from Duke Hospital that comes up with another way of naming their lab. So data sources change. The data sources are dynamic. So how are you supposed to keep up to task with organizing that? So I am very open to ideas of how to do this in a more automated fashion. We've been asking as well, can you just kind of cluster lab values based off of the result and based off of the units and just automatically define what is a hemoglobin A1C, but until those are built and validated, we can't support the innovators who are coming to us for data to build their stuff.
That's like, I mean, we in cardiology, we've done that to some degree by creating national registries where everybody's using the same registry and they're using the same variable definitions. And you spend, once you've got that work done, which takes a long time and is painful, but once it's done, relatively speaking, until you want to add new stuff. And that's what this sounds like it's crying for, is that you just need to get enough people to agree on how to do stuff or to create a common language that then you're not solving those very basic technical problems.
And I think that both are happening in parallel because in other parts of Duke, most of the conversation is around what is the common data structure that we want to agree on for how these lab values will be standardized. But the problem we run into is what do you do in the review mirror when you try to look back and what was already generated. So
What Steve Jobs does is he just flushes it. He says, I'm not supporting that anymore. I'm starting over again. And we put up with it because his product is still better.
Just a couple comments. I wanted to thank Will and Mark again for really getting into nitty-gritty enough detail to allow us to understand how actually difficult a seemingly simple problem should be. Luckily, I think that the winds of change are blowing around. There is infrastructure nationally that is supposed to make all of this easier. Hopefully people can agree on interoperability, frameworks and definitions to allow some of this to be standardized. I was hoping to ask Dr. Curtis a question. She snuck out. But with larger efforts across the country that are hopefully creating common data models for more real-time analytics of relevance to key stakeholders like the FDA, Medicare, hopefully we'll get somewhere beyond where we had to sort of work from here. An anecdote of how far we've come though in 10 years. When David Matcher was here and I came on faculty about 11 years ago, we were funded by a small pot of money, similar in size to what these projects had, And in 1 year, we were not able to do even the basic mapping because of even more thick and high data silos that existed back then. So I will say that there's been progress locally. We have a really long way to go, but it's nice to see that we've actually made some improvements. And now that actually some of that data is actually being used to impact patient care. So I also wanted to highlight Suresh Balu, who helps direct DHI. He had to leave early, but just want to thank DHI and reach out to you guys to sort of reach out to them to foster new collaborations. So great. Thanks again.
Thank you, Atal.